Okay guys, so you thought you were done with binomial in C2, but hurrah, you're not at all. It's actually very simple in C4 really. If you got the hang of the C2 binomial expansion, the C4 one isn't much different. In fact, I think they've given you a topic for free here, okay? But there are a few subtle differences that you need to be aware of. So let's remind ourselves of our binomial expansion formula. So 1 plus x, normally we'd write equal to, didn't we? But we're not going to do that now. We're going to write approximately equal to, and I'll explain why in a second. 1 plus nx plus n minus 1, 2 factorial, x squared plus n minus 1, n minus 2, 3 factorial, x cubed, plus yeah? Now the reason why this is different and why this is approximately 2 and why you have a double dots here is because C4 has a subtle difference that this binomial expansion will go on forever. The reason why it will go on forever is because you'll be looking at our n term here, which is either a negative number or where n is not a member of integers, so is not an integer, okay? So n is not an integer. And this sort of explains why this would go on forever really, doesn't it? Because if we had, say, n equals minus 1, this is 1 plus x to the minus 1, approximately equal to 1 plus minus 1 x plus minus 1 minus 2, 2 factorial x squared plus ... These would never terminate, would they? As we go on forever, our n terms will never terminate to a solid 1, okay? Which is what the difference was in C2. And the same would be said for a fraction, if n was a fraction, negative or positive, okay? So, what we introduce in C4 is this idea of validity, and you'll learn why this validity thing works, perhaps at university. It's way beyond our scope, but for now, you guys need to be aware that this expansion converges towards a number if and only if our x value, our mod x value, is less than 1, okay? So it is valid if here to say the expansion converges to a number. So if in here we had, say for example, 2 plus 3x to the power of 10, we would, as normal, take the 2 to the 10 out. So this would be 1 plus 3 over 2 x to the power of 10. And then you would expand as normal, but you would then say that this is valid at 3 over 2 x is less than 1. So therefore we must have, because we must leave it in terms of x, must be mod x is valid for 2 over 3. Okay? So I'll do some examples in the next slide, but it's not going to be exhaustive. You guys, that is it. That is the difference. Okay? So let's do some examples now.
You've got your